In this video, we are going to work with the mean. I'm going to set up my page. You can see I have my horizontal and vertical lines ready, and I'm going to put the date at the top along with the topic, which is means and outliers. The essential question that we'll put at the top for this video is, how does the mean change if we add one more piece of data? By now, we all remember what the mean is, right? It's the measure of center that you get when you combine all of the data and then redistribute it evenly. So what we're thinking about now is what will happen to our mean if we add one more piece of data. Will the mean change? To know that, we might want to know a little bit more about a term called outliers. We will talk more about outliers in other parts of this unit too, but for now, we need to know that outliers are values that lie far from the center of the data. They're pieces of data that don't seem to fit in. This might be because they are much higher or much lower than the rest of the data. For example, if I ask people how many hours of reading they do each night, and I get the responses of 1, 2, 1, 3, 2, 1, 1.5, and 5, then 5 seems out of place, right? It seems a little bit larger than most of the other answers. I might call this the outlier. An outlier can have a big impact on our mean. Let's look at a table of the number of books students read over vacation. The first thing I'd like you to do is find the mean of this data. So go ahead and pause the video, take a moment, and calculate the mean number of books that were read among these students. Hopefully you found that there were 77 books that were read by all 7 students. So if we distribute that by dividing it among the 7 kids, we get that the mean is 11 books per student, right? So the question is, what do you think will happen if we add one more person? Let's add Anna, and let's say Anna read 12 books. Do you think that her information will change the mean? I don't think it will change the mean very much. The mean is already 11, and her number is pretty close to that. Let's actually do the calculation and see what happens. When I add up all of the books now, right, I get 89, but this time I'm going to divide it by 8 kids instead of 7 because Anna's our 8th student, and the mean ends up pretty close to 11, right? It's 11.125, 11 and 125 thousandths. That's really close to 11. The mean didn't seem to change much, so Anna's value didn't really impact our mean too much. But then one more student comes in to answer, Austin, and he says he read 37 books over the summer. I've added his information in blue to my table. I can tell already his answer is much greater than everybody else's. I would call his answer an outlier. What impact do you think that might have on the mean? Write down a prediction before we calculate. Go ahead and calculate the mean now with Austin. Remember, we have 9 people to think about instead of the 7 that we started with. Let's find the mean by adding the new sum, including Austin's response, and then we have to divide it by 9 because we added a 9th person. When I find my sum, I found that there are now 126 books that were read by these students, but this time I need to divide it by 9, and I'll find my mean. What happened to the mean? It went up significantly. Austin was an outlier, and his answer was so much larger that it pulled the mean, the average, up from 11 all the way up to 14. Thinking back to our essential question, if we add one piece of data while we're calculating the mean, a couple things might happen. When we added Anna, not much changed because her number was not that far off from most of the other answers and from what the mean already was. But when we added Austin, right, his answer was an outlier, and so it did have a significant impact on the mean. Feel free to ask any questions in the margins. Be ready to share anything you'd like for class, and we'll have some chance to practice this in class.